In week 2, we discussed how to prove an if command correct, and that eventually led to a worksheet that guided you through that proof of correctness. What we're going to do now is we're going to take that worksheet and we're going to turn it around. We're going to have the worksheet guide us through how to derive the if command correct, hand in hand with its proof of correctness. Okay, so here we have a prototypical if command. We have the precondition Q, the postcondition R, and we have left ourselves some room to fill in guards and guarded commands. So what is the strategy? Well, the strategy is to come up with some guard G0. Once you know what that guard G0 is, then you're left with a simpler subproblem of determining what the command S0, the guarded command, should be. And notice that you know the precondition for that guarded command, G0 and Q, and the postcondition for that command, R. That's what the worksheet for proving an if command correct told you. At that point, you can then ask the question, does Q imply G0? And if the answer is yes, then you're done. And if the answer is no, then you have to come up with another guard. You go through the same process to come up with another guarded command, and then you ask yourself again the question, does Q imply G0 or G1? And if the answer is yes, you're done, and if not, you continue. Well, so what's the insight? Well, you need to find the guards. And what do we know? We know that Q must imply G0 or G1, etc. So you need to keep finding guards until that becomes true. So let's look at an example. The example is to compute z equal to the absolute value of x. And we may go about this really naively. The precondition is true. The postcondition is that z is equal to the absolute value of x. And let's guess a guard. Well, we might guess that x is equal to -1. What do we do if x is equal to -1? Well, we derive the guarded command. And if you go through the motions of what you learned earlier in this week, you find out that z is equal to 1. And then you ask the question, does true imply that x is equal to -1? And the answer to that is no. So then you have to find another guard. So you might guess that x is equal to 1, and you pick that as your guard. And then you go through your motions again. You find the guarded command z is equal to 1. You ask the question, does true imply x is equal to -1 or x is equal to 1? And the answer is no. And obviously you're going to be busy for a while if you go and look at integers one at a time. And as a matter of fact, you would get an infinitely large if command, and that is highly undesirable. As a matter of fact, it just doesn't work. So obviously we need to be a little bit smarter. And how could we be smarter? Well, what do we know about the absolute value? We know that there is the case where x is greater than or equal to 0, and there's the case where x is less than or equal to 0. So the space of all integers very naturally can be broken up using two different predicates. And we look at the first one, x is greater than or equal to 0. That then gives us a precondition and postcondition for the command S0. Then we can apply the techniques we learned earlier to find that z should be equal to x. And notice that we filled in the proof of correctness along the way. And then we say, well, what about if x is less than or equal to 0? We similarly derive the guarded command for it, as well as its proof of correctness. And then we ask the question, does true imply x greater than or equal to 0 or less, or x less than or equal to 0? And the answer is yes, and therefore we're done. So what's the summary? Simply keep adding guards until Q implies the disjunction of the guards that you have found. For every guard, what you do is you solve a simpler subproblem, namely the problem of finding command SI. Now, you can obviously only have a finite number of guards, and as a matter of fact, you shouldn't have too many or your code would become unreadable. Therefore, you should use what you know about the postcondition R to guide you.